So far in our discussions of ionic compounds, we've discussed binary ionic compounds. We've talked about how to write those chemical formulas, how to write the names, and then we also introduced transition metals. So the first type of ionic compound that we need to be familiar with are binary ionic compounds. And remember, a binary ionic compound just contains one metal and one nonmetal. The other type of ionic compound that we also need to be familiar with are what are called ternary, okay? And ternary, basically, ter just stands for three. It really just means more than just two atoms. So when you deal with a ternary ionic compound, you're dealing with what is called a polyatomic ion. Okay, and again, atomic just means atom, and poly means many. So it's a many atom ion. So most ions are like Cl minus, Br minus, Fe3 plus, etc. Okay, those are not polyatomic ions. Okay, a polyatomic ion is, you can actually see 10 of them listed right here, is notice that every single one of these has more than one atom in it. So, for example, ammonium, which we've already mentioned, is NH4 plus, and that's a positively charged ion. And then you've got nitrate. The formula for nitrate is NO3 minus. Acetate is C2H3O2 minus. You've got bicarbonate, HCO3 minus. For example, baking soda is sodium bicarbonate. You've got chlorate, hydroxide, sulfate, carbonate, peroxide, and phosphate. Okay, now these are a little bit different when you write the name for them, or when you write the name for them, you don't have to change the ending to IDE. So when you write a chemical formula with a polyatomic ion, just like before, you cancel out the charges. Okay. Sometimes though you will need to use parentheses so you can show that you have multiple of that whole polyatomic ion. Okay. So for example, with Mg2 plus and the acetate ion. Okay, so Mg has a positive 2 charge, acetate has a minus 1 charge. So when we put those together, what do we need to do? That positive 2 needs to come down here, but we want to show that there's two acetates. And again, acetate is that whole C2H3O2. So what do we need to do? Notice we put parentheses around the whole thing and put the 2 outside of it. Okay. And again, like I said, when you write the names of them, like these first examples here, you simply, you don't change the ending to IDE. Whatever the polyatomic name is, that's the name that you use. Like binary ionic compounds, though, we have the ones that are always +1, always +2, always +3, but then we also have those transition metal ones as well. So if it has a transition metal, you have to use the Roman numeral. So let's go through these next ones together as some more examples. Okay, so FeNO3. So Fe is iron, NO3 is nitrate. So I'm going to write iron nitrate. Okay, and again, I know it's nitrate because I come back up here and I look and I go, oh yeah, NO3 is nitrate. Okay, but then remember that I have to think, okay, do I need a Roman numeral or not? Remember, every time with a ionic compound, you want to ask yourself, do I need a Roman numeral here or not? And in this case, you do, because iron is in that transition metal area, and it does not, and it's not aluminum, zinc, or silver. So, since nitrate has a -1 charge, and there's 3 of them, that's -3 all total. So iron therefore must be +3. So we write that as iron 3. Roman numeral 3 nitrate. Okay, letter B. Again, this is the easier part. Ag is silver, and SO4 is named sulfate. And again, I kind of think before I write it down, should I leave some space for a Roman numeral, or am I okay? And remember, with silver is one of those 3 transition metals along with aluminum and zinc that never changes its charge, so we don't need a Roman numeral. So the name of that is simply silver sulfate. Okay, sodium and phosphate. Sodium is in the +1 column. It's always +1, so it never needs a Roman numeral. So this is simply sodium phosphate. Okay, BeOH2 is beryllium, and notice that the OH has the parentheses and the 2 outside of it. Okay, this one's a really easy one. Well, we're going to see it here in just a minute. Over here on letter K. So beryllium is BeOH is hydroxide. Beryllium again is always +2. Remember, if it's always that charge, then you don't need the Roman numeral. Okay, so this is simply beryllium hydroxide. Okay, and then letter E. Cu is copper. ClO3 is chlorate. So copper is a transition metal that does change its charge. So I'm going to leave a little space there. I'm going to put the copper. I'm going to put the chlorate. And now the chart. Now to be careful here, because this is not 3 chlorates. Notice that chlorate is ClO3 minus. So that's 1 chlorate. Okay, if there were 3 chlorates, it would have to look like this: ClO3 3. Okay, but just ClO3 has a -1 charge, which means the copper therefore must have a +1 charge. So it's copper 1 chlorate. Okay, letter F is strontium, and CO3 is, go back up and look at it, carbonate. And strontium is in that second column. It's always +2. So we don't need a Roman numeral. Letter G, NH4 is ammonium. And Br is bromine. Be careful, this is not, the polyatomic ion is in the first part, not the second part. Okay, so remember, ammonium, and do I put bromine? Okay, remember if it's like a binary ionic compound, you have to change that ending to IDE. So that's ammonium bromide. Okay, and then our last one here, Pb is the chemical symbol for lead. And I remember that like a PB and lead sandwich, like a peanut butter and jelly sandwich, but a peanut butter, don't ever have a peanut butter and lead sandwich. That would not end well. Okay, so Pb is lead, and it is a transition metal, so we're going to need to put something in Roman numerals. That is acetate. Okay, and now acetate has a -1 charge, but there's 4 of them. So that's a -4 charge all total on the acetate, so the lead has to be +4. So remember that is IV on that. Okay, let's go over to the other column here. Zinc bicarbonate. Again, the first thing you always do, write the symbols with their charges. So zinc, remember aluminum's +3, zinc's +2 always, and silver's always +1. So zinc is +2. Bicarbonate, I just go back up and look, it's HCO3 with a -1 charge, so that 2 needs to come down here. So it's going to be ZnHCO3, 2. Okay, letter J, vanadium 3. Vanadium is the symbol V, and with a Roman numeral 3, we know that means it has a charge of +3. Sulfide is just sulfur with a -2 charge. So this one's not a polyatomic ion one at all. And again, we know that. If it was, that would have to say sulfate. Okay, remember, sulfate doesn't change the ending, but sulfur, instead of sulfur, becomes sulfide. So notice it's just S. So that becomes V2S3. So this is what I was talking about earlier with nickel. It has a Roman numeral 2, so it has a +2 charge, and hydroxide has a -1 charge. Again, having taught this many, many years, this is the biggest mistake students make, is they go, oh, okay, I need to put that 2 down there. But because there's no number after the H, they very, very often forget the parentheses, okay? Because it's really easy to just write NiOH2, because the reason that triggers your brain for the parentheses is there's a number there. But with hydroxide, there isn't. So you have to be real careful. Make sure you put those parentheses around the hydroxide there. Okay, lithium peroxide. Lithium has a +1 charge always. Peroxide is O2, 2-. So our formula is going to be Li2. That 2 comes down here. O2. And this is one of those times where you do leave it. Like, remember we've talked about before how you have to reduce those the numbers if you can. With peroxide, you don't do that. Okay, remember that if you have like even if you had, I'm trying to think of an example here, like Pb4 plus and O2 minus, you'd write Pb2O4, but then you go, oh, I got to reduce those to PbO2. Okay, when it's peroxide and only with peroxide, like hydrogen peroxide is H2O2. You don't reduce that down to HO. Okay, and we know that because we know that the actual formula of hydrogen peroxide does have 2 hydrogens and 2 oxygens in it. Okay, letter M, ammonium carbonate. So ammonium is NH4 plus. And guys, anytime you're not sure, like I don't see this on the periodic table, it's probably up in that ion list. Okay, and ammonium is a pretty common one that. Okay, most of the time the positive ion, again, is going to be a metal that's found on the periodic table. The only time you're going to find that it's not is with ammonium. Okay, so there's +1 on ammonium and -2 on carbonate, so that 2 has to come down here. So NH4 2CO3 would be correct. Iron 2 bicarbonate means iron has a +2 charge, and bicarbonate is HCO3 minus. So again, switch those two. So it becomes Fe parentheses HCO3 parentheses 2. Barium chlorate. Barium has a +2 charge, and chlorate is ClO3 minus. So again, the 2 is going to come down here. So Ba parentheses ClO3 2. And then manganese, that's a 7, guys. So Mn 7 plus. And then oxide is -2. So we just switch them. Mn2O7 is the correct response. Now, these are the 10 I want you to be familiar with. I want you to know these ones right here. Okay? However, I can give you other ones. There's tons, there's thousands of these polyatomic ions. Those are kind of the 10 most common ones, but there's lots of other ones as well. And so if I give you a different one and tell you its name and its formula, you should be able to write a chemical formula or give me the name of a formula as well. So in this case, if I say oxalate is C2O4 minus, which it is, and then I say write the chemical formula of lead 4 oxalate, you're going to go, okay, just what I've done before. Lead 4 means it's Pb4 plus, and oxalate, he told me, was C2O4 minus. I'm going to switch those two, so it's going to be Pb2 C2O4 but then I go, oh, I can reduce those, and so I'm going to divide both of those by 2, which means that becomes a 2, and that is the correct response. Okay, or example 2 here. Borate is BO3 3 minus. Write the chemical formula of titanium 2 borate. So titanium with its Roman numeral 2 means it has a +2 charge, and borate is BO3 3 minus. So in this case, again, we're going to switch those. So we're going to get Ti3 BO3 2 is the correct response.